In this video tutorial, we are going to discuss exponents and powers. We have one number here, which is 1 and followed by 53 zeros. Imagine that you have to write this number somewhere. So what are you going to do? Are you going to write this complete number? What if we have a shorter way to write this number? Now let's discuss that, because that is related to exponents and powers. Suppose we have to write 1000, right? And we can write this 1000 as 10 times 10 times 10. And this can be written as 10 cubed or 10 raised to the power of 3, right? We have discussed these things in our previous lectures on algebra, arithmetic and all. So let me quickly revise this. We can write this as 10 raised to the power of 3, or 10 cubed, or third power of 10. Okay, so 3 zeros here. What we do, we simply write 10 and then we put 3 here. Why? Because this 1000 is actually 10 times 10 times 10, 10 into 10 into 10, right? So since this number has 53 zeros, this number has 53 zeros, this can be written as 10 to the power of, raised to the power of 53. What have we said? What we say this? 10 raised to the power of 53, or 53rd power of 10. Usually we use this one. Okay, now this number 10 raised to the power of 53, in this number, this 10 is called base. Similarly here, this is called base, and this power, that is this number here is called either power or exponent. Same thing here, this 53 is called either power or exponent. Right? So this is the concept of exponents here. You can see that this large number, very large number in fact, can be written as in a very smaller way. Okay, 10 raised to the power of 53, where 10 is the base and this power or exponent is a number that this 10 is raised to. Okay, so if when we write, let's say when we write as this number as 1024, this number 1024, you know that this number can be written as 2 times 2 times 2 times 2 is 4 times 2 is 8, into 2 is 16, into 2 32, into 64. So 1 2 3 4 5 6, then 7, then 8, then 9, then 10. So this is actually 1024 can be written in this way. This is how many 2's we have? We have 10 2's, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64, then 128, then 256, then 512, and then 1024. So this is 2 raised to the power of 10, right? 2 raised to the power of 10. So in this case, 2 is the base, and this 10 is the power or exponent, right? So this is one use, right, to write a very large number in a very shorter way. And then imagine that somewhere you have to compare 2 raised to the power 10 and someone asks you 2 raised to the power 8, which is larger or smaller, in order to compare. Well, there are many different uses of exponents and powers. What we are discussing here is a very simple discussion, very basic discussions. So I hope now you are clear with base and power exponent, and let's talk a little more about this. It's not only that your base can be positive number, your base can be negative number as well. Okay, your base can be negative number as well, right? Like if we write here, this is 2 raised to the power 10. If I write minus 2 raised to the power 10, if I write minus 2 raised to the power 10, right? So in this case, clearly this is base, minus 2 is base, and this 10 is actually the exponent of power. Let's take a few more examples. So if we want to write 81 as 3 times 3, 9, times 327, times 3 is 81. So this is actually what? 3 raised to the power of 4. So 3 is the base, and 4 is the power or exponent. Okay, so not only the base can be any specific number, like now if we are discussing about algebra, we have learned about algebra, right? So let's say that a is any variable, and if I write this as a times a times a times a times a, so a into a into a into a and into a, how many a's we have here? We have 1, 2, 3, 4 and 5. So a to the power of raised to the power of 5, right? So a is the base and 5 is the power. Similarly, if this is a times a times a times a times a times, imagine that this is 1000 times. We are multiplying 1000 times a. So this becomes a to the raised to the power of 1000. A is the base, this is the power or exponent here, right? Now let's take one more situation. Let's say that we have one number, let's say 225. We have this number 225. Now do one thing, do prime factorization of this number. So if we divide with 3 first, let's divide this with 3. So if you divide this by 3, you get 75. Now further divide this by 3, you get 25. Right? Further divide this with 5. Now you divide this again with 5. Right? So you get 1. So if you write this 225 in the form of prime factorization, you write this as 3 times 3, right? 3 into 3, then into 5 into 5, right? Now, this is what 3 to the raised to the power of 2. Why? Because we have 2 times 3. Times, how many times do we have 5? We have 2 times, right? So we can write in the form of base and exponents in this way, right? So imagine that if we have in the same way what we have written here, if we have in the form of variables, let's say we have a times a times a times a times b times b times b, a into a into a into a into b into b into b, then into c into c. Imagine this is the condition, situation. So how many a's we have? We have 4 a's. So a raised to the power of 4 into how many b's we have? We have b raised to the power of 3, or we can say b cubed, right? We have learned this. Cubed and squared we have learned. So a raised to the power of 4 into b raised to the power of 3 into c raised to the power of 2, or c squared. Just what we have done here, exactly we are dealing with variables. What if we don't have exact numbers, we have variables here, right? So we are actually bridging, we are forming a bridge between algebra and arithmetic. This is in the form of numbers, so this is in the form of variables. So actually this is what the concept of algebra. So this is the important thing, that we can write numbers. Imagine that we have number like 625. Let's say we have 625. So if you do the prime factorization of 625, what do we get? We get 326, no, we could 5 only. So 5 times 125, right? And then 5, 5, so we can write this 625 as 5 times 5 times 5 times 5. This is 5 raised to the power of 4. So this is the basic introduction to exponents and powers.